video is going to be an introduction to section 3.4, and in the upper right hand corner I have the section number down. What it is going to be a system of equations with 3 variables. So note we have x, y, and now we're going to toss in a z. You're really just going to be figuring out what x, y, and z equal to make this system have a solution. However, I want you to think about things that change in a system of, with 3 variables. So with 2 variables, we had points in a plane. Now with 3 variables, you're going to have points in space. So you're going to have an x-axis, and you'll have a y-axis, and then you'll have kind of a z-axis going through everything. Now I obviously have a horrible way of trying to get you to visualize a point in space. So I would highly recommend actually go to your textbook and take a look at it, because it's pretty cool to envision a point in space. So now instead of ordered pair x-y coordinates, you're going to have an ordered triple. So maybe your solution will be 1, 5, -2, something like that. So that's your ordered triple now, because that's your x, y, and z coordinate. And again, that's a point in space. You will be looking for where 3 planes intersect. So 3 planes could intersect, and that could be at one point. They might not intersect. Envision like the ceiling and the floor and this ceiling below you if you were in a 2-story building. They are parallel to one another and would never intersect, so you might have no solution. It might be the same plane on top of it, each other. Again, that would be in all solution situations because the planes intersect infinitely. So similar idea, right? But it's planes instead of points in space. So what you're going to be doing is you're going to be taking your elimination process and you're going to be building on it, and it's going to get bigger. Okay, now I'm going to walk through an example, not in this intro video, but what I'd like you to do is think about the steps that are going to be involved. So if I could take these 2 equations and eliminate a variable. So for example, I could double equation the first equation, right? I could multiply all of these by 2, or excuse me, -2, and then that would eliminate the x. Well, then maybe I would take these 2 equations, 2 different ones, and eliminate x again. I'm going to have a system of equations then with a y and a z, and I can whittle my way down to figuring out what then y or z is, and then work my way back up to figuring out the other 2 remaining variables. Now, these are the steps involved, and you may not need to necessarily write these down, but obviously pause the video and do so if you feel like it will benefit you. But this is the method that you're going to use for 3 variable system. Okay, so step 1 is rewriting the linear system in 3 variables as a linear system in 2 variables by using the elimination method. Okay, now when you do this, you're going to, I'm just going to put in a little disclaimer, you're going to eliminate the same variable twice. That's probably obvious. You don't want to eliminate x once and then suddenly turn around and eliminate y, because you'll still have x, y, and z in your 3 equations. So eliminate the same variable twice to get rid of completely that variable. Step 2 then is to solve the new linear system for both of its variables. Okay, so maybe you solve for x and y. Maybe you're solving for x and z. Maybe it's y and z. It totally depends on the situation. Step 3 then is to substitute the values that you found from step 2. Okay, so if you solve for x and y up here in step 2, then you're going to plug those into an equation and figure out your remaining variable z. And then 4th step, and you should be very used to this, of course, is just checking your solution. So make sure that it truly does work out in all 3 equations. Okay, then important down here, if you obtain a false equation, like you end up, your variables all wipe out and you end up getting 0 equals some number that's not 0. Obviously that's not a true situation, so then you're going to have no solution. So a false equation, with no variables of course, is no solution. And then opposite, if you don't obtain a false equation, So it's true, right? But you obtain an identity like 0 equals 0. So again, your variables all wipe out, but it actually gives you the identity instead of a false equation. Then you have infinite solutions. So you should be familiar with those two from 2 variables that does not change in a 3 variable situation. Now, as you watch these videos, it'll walk through how you actually solve a system of 3 variables. And again, it's just elimination, but it's just a larger process.